we're going to continue talking about friction, and we've already talked about the three things that friction can do. Friction can slow down an object, friction will stop an object, and friction will create heat. And we've talked about the example of a car and brakes, and when you apply your brakes, the friction makes the tire slow down until it eventually stops. And we talked about how rubbing your hands together to create friction, you'll feel that heat. So we're going to do a little experiment today. And our question, we're going to go through the scientific method. And our question, I had these toy cars, and I wanted to figure out how friction will react on those. So my question that I came up with was, will the friction from different surfaces affect how far the car travels? Cars travel in rain, they travel when it's dry, they travel in snow and ice. So friction is very important when we talk about a car. So thinking about those, I came up with a hypothesis, and if you'll notice, I included the if and then in my hypothesis. So my hypothesis is, if the car travels on a desk, concrete floor, and carpet, then the car will travel further on the carpet. So I think that it's going to travel further on the carpet. That's my hypothesis. We also need to talk about our variables. So our independent variable is what will change. And in this experiment, I'm changing the surface the car travels on all three times. My dependent variable is what may change as a result of those surfaces. So depending on which surface the car travels on, the distance the car travels is what will change because of my independent variable. My constant, what's going to stay the same, is that I'm going to use the same car each time. I have stacked 3 books. I'm going to keep that the same. So the height and the ramp. My ramp is just a dry erase board. So those things are going to be constant. They're going to stay the same with all of our experiments. Okay, so we're going to get started, and Mrs. Jones is going to keep track of our data for us, because we know that when you're doing an experiment, you have to keep track of your data to analyze that in the end. Okay, let's start with our carpet. And you want to roll it. So the car is going to travel down the ramp. All right, from the edge of the ramp, I need to make sure that that's a constant, where I measure from. I'm going to measure from the edge of the ramp, and we're going to say that the front of the car traveled 16 inches. We can't just do that one time, because it could be that something happened. The wind may have blown, or somebody may have hit something. So we're always going to do repeated trials. So we're going to do it 2 more times. Okay, this time, and you saw, this time we're going to say that it traveled 18 inches. So trial 2, it traveled 18 inches. And trial 3, it traveled 14 inches. So in order to do that, we're going to take those 3, we're going to find an average. This is something you'll learn later, but very quickly, Ms. Jones is just going to add those 3 numbers, and then she's going to divide them by the total by 3, because we tried it 3 times. And what was our average?
16 inches.
16 inches. Okay, let's remove the carpet. So this time, the thing that's changing is our surface. We're keeping everything else the same. And this desk, it's not completely smooth. So let's see what happens with trial 1. It hit a bump. Okay, it stopped right there. And we're going to measure, can you get that for me? 61 inches on our first trial. Let's try it again. It went all the way to the edge this time. gonna say 78 inches. And we're gonna try it a third time. And it went to right here this time. 63 inches, Mrs. Jones. So while she's getting that average, we are going to set up and try it on the floor. And I'm going to scoot this back a little ways because the floor does have some little things. But again, I'm using the same amount of books, same height.
The average for the desk was 67 inches.
Okay. All right, here we go. Our first trial is 83 inches. Our second trial is 75 inches. And our third trial is 82 inches. So while she's getting that,
The average for the concrete is 80 inches.
okay, so let's look at that data, and we have to come up with a conclusion. Now remember, my hypothesis was that if the car traveled on the three surfaces, then the car would travel further on the carpet. But if we look at those averages, we find out that on the carpet, it only traveled an average of 16 inches. The concrete, it traveled 80 inches, and on the desk, it traveled 67 inches. So my hypothesis was not correct, and that is okay. A lot of times your hypothesis isn't going to be correct. But in my conclusion, I need to go back and write that. Instead of me writing it, I'm just going to say it. But my conclusion would be that after doing the trial, the car traveled furthest on the concrete floor. So my hypothesis was not correct. And that would be...
It traveled farther because it was...
And why did it travel farther? Why do you think? Because there was less friction on the concrete floor than there was on either one of these.